Hello students and welcome back to my channel. In this video I'll be discussing questions which were asked from electrostatics and the date was 29th of January 2024 JEE mains. This is probably the 5th or 6th video. Students, in continuation with the other videos, you can just check the other videos for questions based on other topics. So starting from this question number 27, students, two charges of 5q and minus 2q are situated at the points 3a0 and minus 5a0 respectively. The electric flux per square of radius 4a. So this is based on Gauss theorem, students. This is based on Gauss theorem. So suppose we have a sphere. So this is the sphere, students, and so this is the x and y axis I have taken. Now there are two charges. One is 5q located at 3a0. So probably 3a0 will be somewhere here, students, because the radius is clearly given as 4a. So 3a would be a point which is inside the sphere. Okay, right. Then the next charge is minus 2q, which is minus 5a. 0. So minus 5a should be somewhere here, students. Okay, minus 5a. So 5a below the origin here. So there is another charge which is minus 2q. So we require the electric flux through the sphere. So we require the electric flux. So the electric flux as per Gauss theorem is 1 by epsilon 0 into the net charge enclosed within the Gaussian surface. So this sphere itself is the Gaussian sphere for us. So we have to treat this as Gaussian surface. So that means 1 by epsilon 0 into what is the charge enclosed? Naturally the charge enclosed is only plus 5q. So we'll go with the second option, 5q by epsilon 0. Then moving on to the next question, that is 28. An electron is moving under the influence of the electric field of a uniformly charged infinite plane sheet S having surface charge density sigma. The electron at t equals 0 is at a distance of 1 meter from S and has a speed of this much. The maximum value of sigma if the electron strikes S at t equal to 1 second is this. Then the value of alpha is. So here, students, you have, suppose this is the sheet of charge. This is a sheet of charge. So the electron is at a distance of 1 meter, and also it is moving at 1 meters per second. It is moving at 1 meters per second. It might move in this way, in this way, in this way. Just the speed is given. Speed is given as 1 meters per second. We don't know about the direction. But given that, we have to find the maximum value of sigma if electron strikes S at 1 second. So that means electron could go like this, or it can go like this, it can go like this, because anyway it will, the sheet of charge will attract the electron. Sorry, students. So it can go like this as well. Since we have to obtain the maximum value of sigma, we should ensure that the velocity direction is farthest away from this. You have to understand this basic concept, students. When the velocity of the electron is farthest away from then we require maximum value of sigma to achieve that situation. Okay, students. So that means velocity is in this direction. So we'll apply this formula. S is equal to ut plus half at square. Okay. So taking the rightward direction as positive, we have 1 minus 1 is equal to 1 u into 1, because time is also given as 1 second, minus half acceleration will be force by mass into t square. Okay. So therefore force upon 2m is equal to 2. Now force is electronic charge into electric field. Okay students. Now electric field due to a sheet of charge, as you know, is sigma by 2 epsilon 0. Sigma by 2 epsilon 0. Therefore the maximum value of sigma will be 8 m epsilon 0 by E. So alpha is 8. As you can see, alpha is 8. Then moving on to the next question, question 29. An electric field is given by this. You can see it has I component, J component and K component. The electric flux through surface area of 30 I cap lying in the YZ plane. So this is the x-axis, the y-axis and the z-axis. Okay students, now the area is 30 I cap. I cap is in this direction, so this is the area. I cap is in this direction. So only this electric field component parallel to x-axis will only be the lines of force crossing this in a perpendicular manner. The y component and z component will be running parallel, and as you know, when lines of force are parallel to the plane of the area, no flux contribution will be there whatsoever. So there is no flux contribution due to the y component as well as the z component, because these field lines are parallel to the plane or parallel to the surface. So the contribution to flux will be only due to the electric field in the x direction, that is x component. And you know, when the electric field lines are normal to the surface, simply use E A into cos 0. So electric field intensity is 6, area is 30 meters square, cos 0 is 1. So this will be 160 SI units. Then moving to the next question, that is question number 30. If 16 ohm wire is bent to form a square loop, a 9 volt battery with internal resistance 1 ohm is connected across one of its sides, a 4 microfarad capacitor is connected across one of its diagonals. The energy stored by the capacitor will be. Okay, so I'll draw the diagram, students. So if I draw the diagram, probably you will be able to understand this. So this is the So this is a square loop. Then a cell is connected here, and with an internal resistance any two adjacent sides. Okay, sides. So I will name this as A, B, C, D. So between A and D you have cell of 9 volt and internal resistance R. Then since it's a 16 ohm, so resistance of each side will be 1/4 of 16, that is 4 ohm. So this will be 4 ohm, this will be 4 ohm, this is another 4 ohm and 4 ohm. Now we have a capacitor of capacitance 4 microfarad connected across the diagonals, it's given across one of its diagonals. So we have to find the energy stored. Energy stored. So in order to know the energy stored, if we can find the potential difference between B and D, which is also the potential difference across the capacitor plates, we can easily calculate it by the formula half CV square. So half C is already 4 micro, just we have to calculate B and put it here. So let us see the current distribution and all. Now students, you can see that the current will flow in this way. Current will flow this way and a part of the current will flow this way. Okay. So you can see this is 4 ohm, 4 ohm, 4 ohm. Altogether 12 ohm, 3 4s are 12 ohm this side and 4 ohm this side. Both are in parallel. So this yellow path and the green path both are in parallel. So we'll try to know the current through the cell. So current through the cell, let us find the effective resistance. So 12 into 4 upon 12 plus 4. Effective resistance between AD. Effective resistance between the cell terminals. So this will be 3 ohm. So the current drawn from the cell will be 9 by 3. So suppose if I is the main current drawn by the cell, it will be 9 volt upon 3. 12 into 4 upon 12 plus 4. So this will be, so 9 by 3, that is, it will be 3 ampere. Sorry, I'm sorry students, I'm sorry. There is a 1 ohm cell here students. So this equivalent resistance is 3 and plus 1. So current drawn from the cell will be 9 upon 3 plus 1, that is 9 by 4 ampere. Now this 9 by 4 ampere, it will get divided in the ratio 1:3 because the ratio of resistance is 3:1. Okay, resistance of this yellow path is 3 times 4, 4, 4, 3 into 4, whereas resistance of this green path is 4 into 1. So 4 into 3, 4 into 1. Ratio is 3:1. So current will be in the ratio 1:3. 1:3. So it will get divided into 4 parts here. So in this side we have 9 by 16, 1/4 of this. Whereas in this side we have 3/4 of this. Alright. Now we simply require the potential difference between BD, which will be nothing but the current flowing through this, which is 9 by 16 ampere multiplied by 4 ohm and 4 ohm, that is 8 ohm resistors. So current flowing through this BCD is this much, and the resistance is 8 ohm. So we have 9 by 2 volt. So here I'll put it 9 by 2. Remember, potential difference between the capacitor is nothing but potential difference between B and A. Okay students. So finally this 4 gets cancelled. Here 2 will be left and here 81 will be left. So X is 81. SI rate. Of course micro will remain here students. Then moving to the next question. Question number 31. In the given figure, the charge stored in 6 microfarad capacitor when points A and B are joined by connecting wire. In the question it is given that, you can see the figure student, these two are connected by a connecting wire. So since this is at a higher potential 9 volt, this is at a lower potential 0 volt, so naturally current will flow this way, and finally this way, and will enter inside earth. So as you can see, these two are in series students, 6 ohm and 9 ohm. Since the same current will pass through this, so we can say that the potential drops will be in the direct ratio of the resistance. So ratio of resistance is 6:3. 6:3. So the ratio of voltage drop will also be 6:3. So 9 volt will get divided into 6 volt here and 3 volt here. Remember, we have to find the charge stored in 6 micro. So we just require the voltage, which we got this. So charge stored is CV. C is given as 6 micro, voltage is 6. So finally we have 36 micro coulomb. Okay students. So 36 is the final answer. That's all students in this video. Thank you so much for watching my channel. Please do subscribe to my channel and also hit the like button. Thank you so much.